Right, so this is lesson 5 for chapter 2, problem solving with rational numbers in fraction form. All of our examples so far have been in decimal form, so now we're going to start looking at fractions. The key things I want you taking away from this lesson are looking at how do you use fractions when they are integers, either adding, subtracting, multiplying, or dividing, and then making sure that you follow BEDMAS or follow your order of operations while you're doing so. The only part of order of operations we won't be using just yet with rational numbers are exponents. So if we take a look at our first examples, so in both example A and B we have two fractions, but neither of those fractions have common denominators. So before we can start adding fractions or subtracting fractions, we need to have common denominators. So we're talking about the same size of pieces or the same amount of money. If we added or subtracted these as is, it would be like you talking about your monies. So taking all of your dimes and quarters and nickels, whatever, all your coins in your hands and just holding them out and saying, looking at all my monies, they're so pretty. Instead, I want you grouping them and saying, okay, well the dimes go together, so that makes this much money, and the quarters go together and that makes this much money. Adding the pieces together that have the same value. So the same thing is true when we add fractions. We need to add the fractions that have the same value or the same size pieces. So right now we have different size pieces. Sometimes we can look at the two denominators and turn one denominator into the other. So we only end up changing one fraction. So in the case of example A, I hope you notice that 2/5 can be turned into something out of tenths by multiplying the fraction by 2. So we multiply the numerator by 2 and the denominator by 2. So that gives us 4/10, take away -1/10. Okay. So now we have the same size pieces. You just went to all that work to make your denominator the same, so we're going to keep the denominator. I hope you notice that we have two negatives, so minus negative side by side, so they cancel each other out to a positive. So this is actually like saying 4/10 plus 1/10. So when we add that together, we get 5/10. And this fraction, I hope you notice, can be reduced by dividing both numerator and denominator by 5. So we get 1/2. So that's in lowest terms. Looking at our second example, again we have two fractions where the denominators are different. So the easiest way in this case to make common denominators is by multiplying them by each other. So we're going to multiply the first fraction by 3 and the second fraction by 7. So the first fraction will become -18/21 plus 14/21. So again, we went to all that work to make the same pieces. We're going to keep that denominator. So now we look and we're going to do some comparing. We compare -18 and +14. The negative is the larger number, and so that means we're going to have negatives left over when we make our zero pairs, and there's going to be 4 negatives left over. Again, I want you to look to try and reduce. Can we divide them both by 10, top and bottom? No. Can we divide by 5? No. Can we divide by 2? Well, the numerator can be divided by 2, but the denominator can't, so that doesn't work. And then we could try 3. Well, the numerator can't be divided by 3, but the denominator can. So this fraction is actually in lowest terms. It cannot be reduced any further, but you should always give it a try. Okay, on the next part of your notes, I'm going to ask you to cross something out because I wrote it in, and then after thinking about it, it actually doesn't make any sense. So we're going to cross this out. Okay, so now we actually do need to put these into common denominators. And we do need to make improper fractions. It does make our life a lot easier. Why I said it didn't in the first place, I'm not sure. But anyways, we are going to make improper fractions first. So easiest way to make improper fractions is, well, you can draw it out, or we can multiply and then add. So we're going to go 3 times 3 plus 2. So 3 times 3 is 9 plus 2. We get 11/3. Plus, we're going to keep that negative there. Negative. So the fraction is staying negative. And when we do our multiplying, we're just treating it like a 1. We're ignoring the negative for now because the whole fraction itself is negative. So we're going to go 4 times 1, 4, plus 3. So 4 plus 3 gives us 7 over 4. And the whole fraction is negative. If you went negative 4 times negative 1, it would give you negative 4, plus 3 would give you negative 1. And negative 7 over 4 and negative 1 over 4 are not the same. So ignore the negative when you're making your improper fraction and just add it back in at the end. So now we have two fractions that are improper, but still no common denominator. So we're going to quickly make a common denominator by multiplying each fraction by the opposite denominator. So we get 44 over 12 plus negative 21 over 12. Okay, so 44 and negative 21, the positive is larger, the larger number, so we're going to have a positive answer. And the difference between 44 and 21 is 23. So we get 23 over 12. For those of you that are working at a more basic level, this might be as far as you get. For the rest of you, I'm expecting you to turn this number back into an improper fraction, or pardon me, into a mixed number proper fraction. So I can take one full group of 12 out of our numerator. Two full groups would make 24, so we're one short. So we have 11 twelfths left. So 1 whole and 11 twelfths is our solution, and 11 twelfths cannot be reduced. 11 is prime, and 12 can't be divided by 11. So looking at our second example, we're going to do the exact same thing. So again, we're going to go 2 times 2 plus 1, ignoring the negative. So the negative's up front, so 2 times 2 is 4 plus 1, 5 halves. That is all negative. Plus 10 times 1 is 10, plus 9, 19 over 10. Don't have a common denominator, but I can turn halves into tenths by multiplying by 5. So now we get negative 25 over 10 plus 19 over 10. And negative 25 is the larger number, so we're going to have negative tenths left over. And the difference between 25 and 19 is 6, so negative 6 tenths, or I notice that both of these are even, so they can be divided by 2. I get negative 3 fifths. And it doesn't actually matter where the negative sign goes. So you could put negative 3 over 5, you could put negative 3 over 5 like that, or 3 over negative 5. Those all actually represent the same value. They're the same thing. Okay? This one, so when you write the negative in front, that one can be kind of confusing because sometimes it just looks like your fraction line got broken a little bit. So I would recommend using one of these first types where the negative is attached to either the numerator or denominator. In between just makes it difficult to read. Okay, so many of you were much better at multiplying and dividing fractions. This is a grade 8 skill, so we're going to do a little bit of review. Again, if you struggle with this skill, please make sure you see me so I can give you some more practice before we move ahead to anything more complicated.
Miss Karen, come to the office, please. Miss Karen, to the office.
As you can see, I'm still at school, and so are the other teachers. Okay, so when we're multiplying our fractions, all we are going to do is we multiply numerators with numerators, denominators with denominators. We don't need a common denominator first because it's changing anyways, and it's pretty simple. So I'm just going to rewrite it. 3/4 times, remember the negative is kind of in between there. I'm going to assign it to the numerator, but again, I didn't have to. I could have put it with the denominator as well. So we go numerator times numerator. So we go 3 times negative 2 over 4 times 3. You might not show that step, but you might need it to help you remember what you do. We get negative 6 over 12. Okay, that's nice. I notice that I can divide them both by 6, and I get negative 1/2 in lowest terms. The other thing you might have noticed, if we go back a step, is that there is a 3 in the numerator and a times 3 in the denominator. Well, timesing by 3 on both just makes another equivalent fraction. So if we cancel those out to start, we would get negative 2 over 4, which also reduces to negative 1/2. So some of you might start noticing that, and you can skip some of that reducing steps by noticing the 3's on top canceling each other out. If you don't notice it and it doesn't really make sense to you, ignore. All right, when we look at B, again, we have improper fractions. We need to, or pardon me, mixed numbers that we need to make into improper fractions. So the way that we do this is 2 times 1 plus 1 gives us 3 over 2, that is negative. Divided by negative 4 times 2 plus 3 gives us 11 over 4. I'm going to move that negative sign so it's easier to see. Okay. Some of you love this. Some of you may not have learned this. Some of you hate this. Whatever it is, you got to do it. The easiest way to divide fractions is kiss and flip. So you can't see this right now, but go look in a mirror. If you want to pause this, go look in a mirror and come back. I want you to make lips like you're going to kiss something. Okay, are you back from the mirror? It should make an X. So when we say kiss and flip, that means you take your fraction, kiss it, so X marks a kiss, and then you flip your second fraction. So 4 over negative 11. Now we just multiply. Numerators with numerators, denominators with denominators. So negative 3 times 4 over 2 times negative 11. If you want to use brackets to keep your integers together, you can, but you don't have to. So we get negative 12 over negative 22. So I hope you remember that a negative divided by a negative cancels each other out, or they become a positive. So this is the same thing as positive 12 over 22. If this is as far as you get, that's kind of a basic level. If you're looking to work more advanced than that, you should be reducing. So I notice that both of these can be divided by 2, and I get 6 over 11. Lowest terms, proper fraction. Again, if you struggle with this, I recommend you do some more practice on your own or see me tomorrow. Okay, at this point, I would like you to try these two by yourself. So you are going to pause this video. You're actually going to stop this video because I'm not going to show it for you. So you're going to pause this, and we are actually going to go through these two tomorrow in class tomorrow. Okay, we're done.